All right, so section 8-4 is called angles of elevation and depression. So the angle of elevation is going to be the angle formed by a horizontal line. So this horizontal line going right here, and a line from that site of the person in the airplane going down to the tower is going to be above that line. So that creates the angle of elevation. This is the horizontal line. Sorry, the horizontal line here, and the angle going up to the airplane creates that angle of elevation. And then the angle of depression is this horizontal line with the line going down to the tower, angle 2 there, creates the angle of depression. All right. So the first thing we're going to look at is a couple pictures, and all we need to do is classify the angle as either elevation, as an angle of elevation, or an angle of depression. So the first one they want us to look at is angle 1. So here we have this person standing right here. Here's a tree, and we've got the ground below the tree. So they want us to look at angle 1. So angle 1 is up here. Here's the horizontal line, and the line that it's going down to the person's eyes, right? That angle 1 there, is that an angle of elevation or an angle of depression? Depression. So all you need to do is say angle of depression, and then you've answered the question. How about angle 2? So you have this person right here, and there's the horizontal line going over to the tree, but then the line that it shares with angle 2 right here goes to the top of the tree. So is that an angle of elevation or an angle of depression? Elevation. Okay. How about angle 3? So there's your horizontal line, and the other angle that it's sharing with goes down to the ground. So that's an angle of depression. And the last one, here's your horizontal line, that's the ground. And the other line that it's, or the other line right here that's sharing going up to the person's eyes creates an angle of elevation. Okay, good. All right, so you guys got those. All right, so the two examples that we're going to talk about today, go ahead and copy down example number 2. Example number 1, you didn't need to copy down, it was just naming them as angle of elevation or angle of depression. But example number 2, copy the question down. It says, what is the angle of elevation for the first big hill of the Nike Women's Marathon? Okay. So you guys might have noticed that I've run a couple races. And the very first full marathon that I ran was the Nike Women's Marathon. And it just so happens that it's in San Francisco. How many of you have been to San Francisco before? A lot of you, bless you. So San Francisco is known for its what? Hills, right? So if you were going to run a marathon and you were going to run your first marathon, would you run one in San Francisco? No. All right. So I'm going to move this up just a tad so you can see the map. So before you run a marathon, you get a map. All right. So here is my map. And the race starts over here at a place called Union Square. At Union Square, they have this big, huge 3-story Nike store. They have a Tiffany's, they have a Macy's, and some fancy stores. And you head out towards the waterfront here, and you run along the waterfront, and you get by the Pier, what is it, Pier 60-something? Pier something, where they have all the good clam chowder and all that. Yeah, so you run down along here, and then you keep running, and then you come around by this fort. And so there's this, when you get to right about here, there's this really steep hill. Thank you. Yeah. And then you head around and you pass by Lincoln Park, and then you come to this area called the Golden Gate Park, because I think it's like right in here is the Golden Gate Bridge. Okay, so you pass by the Golden Gate Bridge, and then the half marathon separates right there. But if you're doing the full marathon, you go down through the park, then you come out, and then you pass the finish. So that's horrible when you're running a marathon, to pass the finish and not be able to finish, to keep going. And then you run over towards what's called Lake Merced, and then you turn around and you head back. And the second time you get to the finish, you actually get a finish. Okay? It's a really long race. Does anybody know how long a marathon is? How many miles it is? How long? 27. Close. You're close. Do you know? 26.2 miles, okay? 26.2 miles is a full marathon. We're going to calculate the angle of elevation for the first big hill. All right, so this is just the street map, but if you notice down at the bottom, they have what's called an elevation map. It's really hard to see because it's in black and gray, but you can see that it starts and you run down next to the water, and then there's this little hill here, and then it goes pretty flat again, but then right between mile 5 and mile 6, it shoots pretty straight up. Okay, so there's a pretty big hill right there. So that's the hill. We're going to calculate its angle of elevation. So we're going to start by drawing a triangle that represents that angle of elevation. So we want this angle right here. We'll call it S, okay? And I'm over here. I've got to run up this hill pretty quick, okay? So on the map, this happens between mile 5 and mile 5.75. Okay? So in 3/4 of a mile is this really steep hill. And the elevation map says that it's 250 feet that you increase in elevation. So basically you're going from basically sea level up to 250 feet in elevation. All right? From 5 miles to 5.7 miles, how many miles are happening in here? 0.75, okay? So we need to calculate how many feet that is. Notice that this is in feet and this is in miles. So we need to get them in the same unit. So we're going to take the 3/4 of a mile, the 0.75, and we're going to multiply it by how many feet are in a mile. Does anybody know that magic number of how many feet are? Yes, so if you multiply 3/4 of a mile by 5,280 feet, you get, and you want to do this on your calculator, 3,960 feet. So instead of writing 0.75 miles, we're going to write 3,960 feet. So now we're in feet here, and we're in feet here. Okay? So we want this angle S right here. So from this angle, we know 2 sides. This side over here that says 250 feet, is it opposite, adjacent, or hypotenuse? It's the opposite. And this side over here that's 3,960 feet, is it opposite, adjacent, or hypotenuse? Adjacent, right? So we've got opposite and adjacent. Which trig function uses opposite and adjacent? The tangent. Tangent uses opposite over adjacent. So we want to get angle S, right? And we know that it's the opposite, which is 250, over the adjacent, which is 3,960. And we need to decide, are we going to use regular trig or inverse trig? Inverse trig. We're looking for inverse trig because we want the angle. So we're going to say the inverse tangent of that ratio, 250 to 3,960, and it's going to give us this angle right here. So if you have your calculator, you're simply going to hit the second button do it? Yeah, okay. And then hit the tangent button. Type in this ratio. So 250, to make it a fraction, you hit divided by 3,960. Hit the equal sign. And your angle S is going to be something like 3.61236378.7. But we don't need to make it quite that long. Let's round to the nearest hundredth. So after that decimal, I have 3.61. Next to it's a 2, so it's going to stay. So angle S is approximately 3.61 degrees. And we've calculated the angle of elevation. That's the angle of elevation for the Nike Women's Marathon in San Francisco. Right? Anybody still copying that down? Got it? I can give it to you if you want it. You're almost there. Okay. All right, so example number 3 is the second marathon I ran.
Wait, what?
So the second marathon I ran was the Ojai Marathon. So how many of you have ever been to Ojai?
What is that?
Right? No, Ojai is a city in California, and it's actually up in the mountains near in LA. There was a fire there in November. You guys remember seeing the fires on the news? Okay, so this little town up there called Ojai, it starts at the top of the mountain, and the race, so you run around the top for a minute, so you're kind of flat, and then after you run kind of the circle, then it's downhill. So this time, I decided, okay, instead of running uphill, maybe I'll run downhill to get a better time. And here's roughly what the map looks like. So you run around the top up in a circle, and then you run downhill. When you get to the bottom, you run down by the beach a little bit, down by here, because this is somewhere between Santa Barbara and LA, so it's kind of Ventura-ish. Okay? You run around down at the bottom. Okay? So this is the map they give you, and then they also give you an elevation map. All right? So you can see that you start at a high elevation, you kind of stay steady for a long time, and then you slowly go downhill, and then when you get towards the bottom, you kind of go flat again. Okay? So this time, we're going to calculate the angle of what? Depression, because we're going down. All right, so using the elevation map, we're going to say that over 13 miles, for 13 miles of the race, you're going to be going downhill, depression, right? Which, if a full marathon is 26.2, 13 is basically how much of it? Almost half of it. 13.1 is a half marathon. So if we're going downhill for about 13 miles of it, about half the race is downhill, we're going to take that and multiply that by 5,280, just like we did in the last example, to see how many feet it is. So you should get 68,640. All right? So this time, we're going to draw our triangle like this. We're going downhill. We'll call this angle T. Here's your right angle over here. And this time, it's 68,640 feet. And on the elevation map, it shows a difference of 750 feet. So you lose 750 feet in elevation. Okay?